Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how you can name coordination complexes or coordination compounds. So the way you're going to work this is, again, these are kind of ionic compounds, but one of the ions, or maybe even both of them, are complex ions involving ligands. But the way you name ionic compounds also applies. It's always the same. It's the name of the ions separately put together. So all you need to do is figure out, like, how do you name the ions. The simple ion, if you've got a simple ion, is just naming it the way you normally do, simply, right? If you've learned how to name ionic compounds before with simple ions, maybe you've also used polyatomic ions. But even then, you're just taking the names of the two ions, putting them together. So in a coordination complex or a compound, you got a complex ion that's going to be require a little bit more to name, but it's pretty straightforward. So let's begin. So let's say for this one, you've got a complex ion here, and you've got a simple ion here. The chloride ion is a -1. So you have two of them. That tells you that the charge is positive. So it's got a +2 charge. So you've got a chloride ion. So let's say chloride ion. You've got two of those. So that means that you've got a +2 for here. So this is a +2 charge, and this is a negative charge. So we're just going to name this chloride. So that's the name of that ion. So that's done. So that's the second part of the name. Now the positive ion is the first part of the name. So we need to name that one. So the way you're going to do this is you need to name the ligands first. Give them a name. So for water, when that's a ligand in a coordination compound, we're going to call that aqua. So for water, it's aqua. And then we have chloride bonded here as part of our coordination complex. And so we're going to give that the prefix or the root chloro. So we have aqua and we have chloro. And then we got to use prefixes to indicate how many of each one we have. So if we only have one, then we don't need a prefix. If we have more than one, then you need a prefix. This is where the Greek prefixes come in, where you have di, tri, tetra, penta, things like that. So we have 5 water molecules, so that's going to be 5. So we're going to do penta. So that's going to be penta. Okay. And then we have chloro, and then we have chromium. So the chromium here, that's going to be chromium 3 plus. Okay, so here, because we have chloride there, so, and then the overall charge is a 2 plus, so that's going to be chromium 3 plus. And so so we got to name that one as well. So chromium 3. So no space there, just chromium 3. And so now that we have all the parts, we just put it together for this complex ion. So we would name the complex ion as, and we got to write it in order, the alphabetical order, with aqua first. So we're going to ignore the prefixes. You don't, when you're writing in alphabetical order, you don't write it with respect to the prefixes. You write it with respect to the root. So here it's aqua, so that's going to be written first. So we have penta aqua, followed by chloro, followed by chromium 3. So that's the first part of the name. This is the second part of the name. To get the name of the coordination compound, put them together. So chloride. So the name of this coordination compound is penta-aqua-chlorochromium 3 chloride. And the only space is between the two names of the ions. Okay. How about the next one? So again, we have a simple ion and we have complex ion. We're going to name the simple one as we normally do. K is potassium, so that's going to be potassium. Potassium. So that's the first part of the name. The second part is this complex here. So we have 3 potassiums. Potassium is a plus. That means that this complex has a 3- charge. So the way we're going to do this is we have here 6Cn. Cn is a polyatomic ion. Cn has a negative charge on it. The total charge is a -3, so that means that iron has a 3+ because the 3+ and the 6- cancel out to give you 3-. So the iron here is going to have a charge of 3, so we're going to call this iron. Well, we're not going to call it iron. It's got a special name. Almost forgot. When iron is part of a negative ion complex, we call it ferrate. So we're going to call it ferrate 3. So ferrate 3 is what we're going to call this. So that's the iron in the complex. And then we have here Cn. That's going to be a ligand, and we're going to call that cyano, right? So cyano is the root for Cn. So cyano. And we have 6, so we're going to put hexa in front of there. Okay, so we got the hexacyano for the 6Cn, and we have the ferrate 3 for the iron. So we put those together, and for the name, so this is the name for this one here. When we put these together, again, alphabetical order, and the first name is the first polyatomic, no, sorry. So the positive ion is written first. So potassium space, and then we're gonna, when we name this complex here, it's all gonna be one word. So we're gonna start in alphabetical order. So the alphabetical order is cyano. So hexacyano, right? Followed by what the only one that's left is ferrate 3. So ferrate 3. So that would be the name of this compound here, potassium hexacyanoferrate 3. Okay. So what's the next one? So here, again, we're going to name this as 2 separate ions, SF4, that's sulfate. So that's going to be the second part of this complex, the second part of the name. So SF4, that has a 2- charge on there. So that means that this has a 2+ charge to balance the charge. So NH3 has no charge on it. We have carbon CO as well. And so we have Mn. So CO, carbon monoxide, that doesn't have a charge on it. Mn is the only thing that's going to have a charge. So that's going to have a 2+ charge on it. So CO, the way we're going to name CO, when we have CO, that's going to be carbon monoxide. We're going to call it carbonyl. So CO is given the name carbonyl. So that's our CO. We only have one, so we don't need a prefix. NH3 as a ligand, that's going to be called, if we look that up, amine. So for the NH3, that's going to be amine. And we have 5 of them, so it's going to be pentamine. So we're going to drop the A, I believe. Let's see. Okay. So we have pentamine would be the name for this. We've got our carbonyl for this, and now we name this. This is going to be manganese 2. So manganese 2 is the name of the metal. So now all we need to do is put this together in alphabetical order. So again, ignoring the prefix, so it's going to be this first. So the name put together, let me put a box around this one so it's not confusing. So this is the name of this one. So then we have the complex first. So first is going to be pentamine. So pentamine, followed by the next thing in alphabetical order, carbonyl. And then the metal, manganese 2. And then followed by sulfate. Sulfate. With a space between. So the only space is between the names of the two ions. And so this is the name of this complex here. And then finally, we're going to do this one. So again, sodium. So we have sodium is first. Sodium has a 1 plus. There's 2 of them. That means that this is going to be a 2 minus complex. We have 4 chlorides. So chloride ions have a negative 1. So we have 4 of them. That means there must be a 2 plus charge on the platinum. So again, chlorine is going to be chloro. So we got to name this complex here. This is going to be chloro for the chlorine. We got 4 of them, so it's tetra. So tetrachloro for the 4. And then we name this here. So PT, when we have platinum, that's called platinate. So platinate is the name of platinum as part of an anion coordination complex. And then it's got a 2 plus there. So we got a 2, Roman numeral 2. Put this together, alphabetical order. So it's going to be sodium. Finally, the name is sodium. And then tetra, chloro, platinate 2. So this would be the name of that complex there. So I hope this was helpful. I hope this all made sense. If you enjoyed this video, please like, share, subscribe, hit the notification bell, make a comment in the comment section. Let me know what you think. Thanks for joining me. I'll see you next time.